Hello, welcome to our last lesson on differentiation. Okay, so in this video I will take you through how to differentiate some specific equations through what we call implicit differentiation. Okay, so first of all, let's recall on something that we did some rules of differentiation. We said that if y is equal to u of x in our previous video, where u depends on x, okay, then our dy dx is given by dy dx is equal to dy du, okay, times du dx. In other words, if let's say u is equal to, let's say, x plus 1 to the power 5, which is the same as y, or let's say y is equal to x plus 1 to the power 5, then we let u be equal to this. Okay, it means y is equal to u to the power 5. Then dy dx is actually equal to du dy, which will give me what, 5 u to the power 4, and times d of u dx, and u is what, x plus 1. Sorry, we will represent u by just x plus 1. Okay, that is what we did in our previous video. We said this will give me 5, and u is what, x plus 1 to the power 4. When you differentiate this side with respect to 1, as you get what, 1. So you get something like 5 x plus 1 to the power 4. This is what you will get from what we call the chain rule. Now we are coming to employ the same idea here in differentiating through implicit. Okay, alright, so let's write a question down or something down to differentiate, and you understand what I mean by differentiation through what you call implicit. Okay, alright, so we said something like implicit differentiation. What is it? Okay, let's say I have this equation, okay, and I've been asked to solve this, find dy dx through this differentiation. Okay, alright, if I'm to differentiate this, then it will be very difficult for us because we don't know how to do this. But we are saying that I should find dy dx, meaning y depends on x. Okay, so if I'm to differentiate this, then what I can do is I would differentiate the whole of this term wise. So I will differentiate the whole of this term wise, and that will be, I first take the y aspect, and I find d of y ds times dy dy. I hope you get, I don't know if you get my point. Something like u is equal to, y is equal to the u to the power 5. We have something like dy dx, differentiating this side was equal to the differential with respect to, so dy du times du dx. Okay, so the same thing here, this is a dy dx. Okay, that is the same as du dx, because here our u is in terms of y, but it's the same y that we are finding. Okay, then you find the differential of this y with respect to y, so it's a differential of this y here with respect to u, but here the y is also dependent on what, y again. So we find differential of y with respect to y, differential of y with respect to x. Okay, I hope you get it, or you're confused. Let me write it all for you to understand more. Okay, so in simple terms, this is what I wanted to say. You are saying that y depends on these two functions, y and x. Okay, and all of these depends on x as well. So if I'm to find the differential of this, then I have to find the differential of this y, the first term, okay, with respect to x, times the differential of the y that we don't know with respect to y, plus the differential of this function x, okay, with respect to x. Okay, then times, or let me keep it that way because it's just x that we want. Okay, there is no function here that is also here. Why we just kept the x of x is that in this function we are saying that this depends on x. So in differentiate, you have to differentiate it in two ways. If I differentiate it with respect to y, then you differentiate it with respect to x, you multiply them as a chain rule. but once in the case of x, we have only x present. Okay, so you just differentiate x with respect to x and you are done. Then ddx of 1. Now here dy dx will still be dy dx. Now differentiate the y with respect to y, I get what, 1. Then plus ddx of x is what, 1, meaning differentiating s with respect to x, and this is equal to 0. So I get the x or dy dx, okay, plus 1 equals 0. So I have dy dx being equal to -1. So this is what we call implicit differentiation. Okay, differentiating by implicit rule or something, differentiating by implicit or something like that. Okay, now let's take a more complex one and solve it, okay, for us to gain more understanding. Okay, so if you solve more questions, you gain more understanding. Okay, so let's take, alright, let's say if you have something like this, yx plus 2x equals 0. Okay, and I want to differentiate this. One thing I should remember is that in differentiation through implicit, all the rules of differentiation is applied here. Okay, so what you do is, since this is just, you treat the y and x as multiplication of two functions. Okay, so what you can do is, first you differentiate the y, okay, with respect to x, then keep this s plus. First you keep the y, then differentiate this x with respect to x, and plus 2 times the differential of x. Okay, we did this in our first video, which is equal to the differential of 0, and that will give me 0. Now if I differentiate y with respect to y, first we said differentiate y with respect to y, and dy will give me what, 1. Then differentiate the y with respect to s, which will give us dy ds, where we don't know. Then x plus y d of x dx, and that will give me what, 1. Okay, plus 2, you got the differential of 2s will give me 2. Okay, and this is equal to 0. So I'll get like x dy dx plus 2 plus y is equal to 0. So I guess I'm like s dy dx is equal to -2 negative y. This whole thing will imply that dy dx is equal to -2 minus y over what, x, and this will be your solution, okay, for your differentiation. So thank you, and this is how you solve differentiation through implicit. Okay, don't forget to subscribe to the channel, because every blessed day will be posting videos on calculus and a whole lot of mathematical problems. Okay, thank you, and see you next time.